Assalamu alaikum. Hi, dear students. This is Dr. Zakir with you. How are you all? I hope you did very well in Calculus 1 and got good grades. Now it's time to begin your journey for the next course, which is Calculus 2. This is for diploma students, GSMA 102, Calculus 2. Okay, welcome back to Dr. Zahir Math YouTube channel. I'm very happy to start this new course or new series with you. And the bachelor course MA102 Calculus 2 will be uploaded soon, inshallah. I hope you enjoyed my videos in the last semester. What do you say in the class? East or West? Dr. Zahir Math YouTube channel is the best, right? Thank you for all your support. I hope you will give me the same support and encouragement in this course too. It's not just about the formulas, it's a journey into how engineers think, solve, and create. Don't worry, I'll walk with you step by step and make it feel easy, even more beautiful. So, are you ready? Let's begin together. GSMA 102 Calculus 2. The first thing you need to do is the rules. Very, very important. The same thing which you studied in Calculus 1. So I'm going to teach you the differentiation rule and the integration rule. Okay, right. So first of all, every places we need differentiation and we need integration also. Keep in your mind. Okay, let's start the first formula, number 1. Okay, right. Take a constant C, any number. Okay, if you take a derivative of a constant, what is the answer? D by dx of the constant C, which is equal to 0, right? And the integration gives, the formula is integral of C dx is equal to, C is a constant, it will come out, and integral dx, which is equal to Cx. And after that, you need to add one more constants. Let me call C1 for this only. Remaining all places, I will call it as C only. Right. Let me give an example now. Right. Suppose I take a number 5. What is the derivative of number 5? Derivative of number 5, according to this rule, it's 0. This is the derivative formula, right? And this is the integration formula, which you already studied in the high school, right? The same idea, integral 5 dx, I'm going to do it. I'll take it 5 out and then integral dx, which is equal to 5. Integral of dx is what? X plus integrating constant C. Right. Let's go to the first formula which you studied in the differential calculus, which is x power n. What is the derivative of x power n? Which is n x power n minus 1. Do you remember that? Yes. So the derivative of x power n is equal to n x power n minus 1. The same thing. What is the integral formula is integral x power n is equal to x power n plus 1 divided by n plus 1 plus integrating constant C. Okay. I'll give you a simple example for this also. Right. Okay. Which is number 4. Right. Let me give a simple example. What is that? Suppose you have x square and you want to differentiate this x square. Differential of x square. What will be your answer? Which is 2x2 minus 1, which is equal to 2x. The same thing I'm going to do integral x square dx. The integration rule is x power n plus 1. 2 plus 1 divided by 2 plus 1 plus integrating constant C, which is x to the power of 3 divided by 3 plus integrating constant C. Okay, right. So let's go to the next formula. What 1 by x function, I'll take it. What is the derivative of 1 by x? I taught in the calculus video, which is minus 1 by x square. Right. And what about the integral formula? If you want to integrate, integral 1 over x dx is, the derivative of x is what? It is 1. So if the derivative of the denominator, which is down, is available in the numerator, which is up, then we can write ln absolute value x plus integrating constant C. You can also simply write ln x plus C also, no problem. Right? So integral of 1 by x is going to become what? Ln absolute value of x. Right. Let's go to the next rule. The next rule is e power x. What is the derivative of e power x? Derivative of e power x is e power x. Same also integration. What is the integral of e power x is? Which is also e power x plus integrating constant c. Okay, right. Let's go to the next rule. I'll give you some examples. E power, for example, you take minus x. Now, what is the derivative of e power minus x? The derivative of e power minus x is e power minus x. After that, the derivative of minus x is what? Minus 1. Okay. So, here you are multiplying, right? So, in the integral, you are going to divide. Integral of e power minus x dx is equal to e power minus x divided by minus 1 plus integrating constant c. Every time you should write integrating constant c. Suppose if you have a limits over here, right? At that time, c will be removed. You are not supposed to put c. Okay, right. So let's go to the next one, that is number 8. I'll give one more example also for this. Suppose you have e power 2x as a function. What is the derivative of e power 2x? The derivative of e power 2x is e power 2x, and then derivative of 2x is going to become what? 2. The same thing, let's do the integration. E power 2x dx, which is equal to, I told you already, in the derivative it will multiply, but in the integration e power 2x over 2, it will divide, plus integrating constant c. Right? Okay. Let's take another examples. Okay. For example, I'll take some example 5x. Let me see the number. 8 and this is 9. Okay, let me take 5x. What is the derivative of 5x? We studied already this one. Take 5 as a constant out, derivative of x. What is the derivative of x? Derivative of x is 1. The same thing we are going to do, integral of 5x dx, which is equal to 5 will come out, integral x dx will be there, right? So 5 will be there, and integral of x is x power n plus 1, which is 1 plus 1 divided by 1 plus 1 plus integrating constant c. So which is equal to 5x power 2 divided by 2 plus integrating constant c. Okay, right. So let's go to the next example. Suppose I will give you like this, x plus x square, some function. So what you will do? You will take a derivative of x plus x square. Whenever there is a plus or minus, we can separate. Not in product, not in division. Keep in your mind. So we can write derivative of x plus derivative of x square. What is the derivative of x? Which is 1. And what's the derivative of x square? Which is 2x. So same idea, I'm going to use it for integration. Integral of x plus x square times dx. This equals, I told you the formula for integration is what? Integral x power n dx is equal to what? X power n plus 1 divided by n plus 1 plus integrating constant c, right? So the same idea I'm going to follow. Here power is what? 1. So this is x power 1 plus 1, which is 2 divided by 2. Plus, what is the power here? It's 2. So x power 2 plus 1 is 3 divided by 3 plus integrating constant c. Right? So these are the basic ideas about algebraic equations or algebraic functions, and then exponential functions, and then constants. Now, the very important thing which you find it difficult is sine theta, cosine theta, all these things. Okay. So let us talk about sine theta. Okay. You talk about sine theta. Let me give you, instead of theta, you will find it x as easy. Sine x. Okay. Cosine x. And then tan x. Right. The reverse. Reverse means reciprocals. Sine x is what? Cosecant x. Cos x is what? Secant x. And tan x is what? Cot x. Now we are going to study the derivative of these 6 functions and the derivative of, and the integration of these 6 functions. Okay, right. So let me write, you have to memorize at a rule. So keep in your mind, just memorize as a rule. Okay, so let me start the trigonometric functions. Number one, so first one is sin x, second one is cosine x, and the third one is tan x. Sine, cosine, tan. Derivative of sine x, which is equal to cosine x, and derivative of cosine x is equal to negative sine x. I hope you remember everything. Right. And derivative of tan x is equal to secant square x. Secant square x. Keep in your mind. Okay. Right. Now we are going for integration. What is the integral of sine x dx? And what is the integral of cosine x dx? And what is the integral of tan x dx? Okay. Right. So it is cosine x here, it is minus cosine x. Keep in your mind there is a minus. Here is plus and here is minus. And integral of cosine x is just sine x. Let me write sine properly. Sine x. Okay, right. And what is the integral of tan x? It is not same like this. It's totally different. And integral of tan x, there are two formulas. Number one is minus ln absolute value cosine x. Teacher, every time do I need to put absolute value? Not necessary, but just have a practice. The second formula is ln secant x. Why? Because this minus goes to the top. Cos x to the power of minus 1 is what? Which is 1 by cos x. 1 by cos x is what? Secant x. So going to be same. So integrating constant you have to add plus integrating constant c plus integrating constant c plus integrating constant c, plus integrating constant c plus integrating constant c. Any one formula, this or this. So sin x is negative cosine x is sin x, and tan x is minus ln absolute value cosine x. Any one you can remember, no problem. Okay. So let's go to the next three rules. What are they? The next one is number 4, number 5 and number 6. Right. The next is cosecant x and the next is secant x and the next is cot x. Next is what? Cosine x, cosecant x, secant x and cot x. Right. So what is the derivative of cosecant x? Derivative of cosecant x is minus cosecant x cot x. And what is the derivative of secant x? Right? Secant x tan x. These are all rules. There is no way you have to memorize. And the next is derivative of cotan x, which is equal to minus cosecant square x. Now, the integration formula you have to memorize. Integral of cosecant x dx is equal to ln cosecant x minus cot x absolute value plus integrating constant c, and integral of secant x dx. Integral of secant x dx is equal to ln absolute value secant x plus tan x plus integrating constant c, and integral cotan x dx, which is ln absolute value sin x plus integrating constant c. You have to memorize this. Right. After that, I wanted to say one more thing. In some places, you will get integral of this functions. And some question, you will get integral of this function. And some question, you will get integral of this function without minus. Integral of this function. So at that time, what should I do? So from the derivative, you can also write integration. Okay. So what is integral of cosecant x cot x? You are going to get cosecant x. Before going to this one, I wanted to say a few words about differentiation and integration. So usually differentiation and integrations are, let me say differentiation and integration, right? Differentiation and integrations are like opposite twins. We can say twins. Twins means what? Twin babies, you remember? Opposite twins. What is the meaning of opposite twins? One undoes the other, right? That's the meaning. That means what? If you know the derivative, you can go backward and find the original function using integration, right? Let me give you a small example and then we'll come back to this formula again, right? So let me explain this one. Just listen here. What is the differential of x square? 2x, right? What's the differential of x square? 2x. Now let me integrate this 2x. So this equals 2x square divided by 2, right? Because what is integral of x power n? It is x power n plus 1 divided by n plus 1, right? Yes. So similarly, this one, what happens? This 2 will come out, integral x dx, right? So this equals what? 2 will be there, x square divided by 2. 2 gets cancels. So you are going to get what? X square. Look at your function. Right? So what's the meaning of that? So differential of x square is 2x, but integral of 2x is x square. What's the conclusion? Differential of x square is 2x, but integral of 2x is nothing but what? X square. Okay. So that is why I told you differentiation and integration are like opposite twins, right? If you go this side, you will get this answer. If you go to the other side, you will get the next answer. So the same thing will work out for differentiation for trigonometric functions, that is trigonometric functions also. Okay, let me take the examples. For example, you take cosecant square x. I'll go back to here. Right. Suppose you want to find the integral of cosecant x cot x. Okay. You will get this one. You will get this one. Okay. And suppose you want to find the integration of this one. Your answer is this one. If you want to find the integration of this one, your answer is this one. So this also you need to remember as a rule. What is that? So let me write the rule also. So integral of cosecant x cot x is equal to, take that minus to the other side, minus cosecant x plus c. Okay, right. Then integral of secant x tan x is equal to secant x plus c. And integral of cosecant square x dx is equal to cot x, take the minus to the other side, plus c. How, teacher? Because what formula I gave you? I gave you the formula for cosecant x and secant x and cot x. What is the formula for secant x I gave you? Minus cosecant x cot x is the derivative. For derivative. Okay, right. Secant x is what? Secant x tan x. Cot x is what? Minus cosecant square x. Now look at here, everybody. So cosecant x cot x, if you do the integration, you will get this minus cosecant x. Secant x tan x, if you do the integration, you will get secant x. Cosecant square x, if you do the integration, this minus will go and you will get minus cot x. So in this way, we can say differentiation and integrations are opposite twins or like opposite twins. You can say like that. I gave you one example from algebraic function and I gave you one example from what? Trigonometric functions. Okay. So thank you for learning with me the basic ideas of differentiation and integration. For every lecture, you have a PDF. Okay. Where is that? Check in the pinned comment and in the description box. Please like, share and subscribe to stay connected. With care and dedication, this is Dr. Zahir signing off from Dr. Zahir Math YouTube channel. See you in the next video. Take care. Bye-bye.